Hello everyone. Welcome. So my name is Daniele. I'm an Android developer and Google developer expert, and I work at Novoda, which is a mobile agency based in London and other cities in Europe. We work a lot with several projects and clients, and something that we do a lot is to promote and to publish and maintain Android libraries. So I'm pretty sure you already used a lot of libraries in your projects. I mean, they are great. They help you achieve the goal of your apps without having to reinvent the wheel every time. You can use what other people are working on. So, I mean, they're spending their time on these libraries, and they are providing you some tools that you can immediately use for your project already. But let's have a quick look at why you should be interested in creating a library, how to maintain it, how to make it grow, and some concept that you might want to think about when you are working on creating a library. So first of all, you need to consider that usually when we are thinking about creating a library, what we want to do is to solve a small problem, something that we have in the current project, and then probably think that maybe somebody else could reuse it and could benefit from the solution in their project. This somebody else could be ourselves in 6 months with a new client, with a new project, and again, we don't want to reinvent the wheel or just copy-paste the code every time. So why not create something more general that we can reuse in several projects? Sometimes it's easy because maybe the solution that we were about to solve, they were so simple that we can immediately use it in different projects. Sometimes we need to do some small changes in order to adapt for the new project. This is usually something that we always consider when creating and extracting some code from the main project to a library. Another good thing about libraries in general in software development is that they break dependencies of the main project into smaller problems and concerns. This allows you to be focused on tackle only one problem at a time and having then a single responsibility for each dependency. Instead of having dependencies and then libraries that can do multiple things, a lot of things, it's good to have some very focused ones, which can also be connected and composed together with multiple libraries in your project. Another very important thing to consider is that libraries, if well done, they prevent coupling. Basically, given the fact that they have a one-directional relationship with the main project. The application depends on the libraries, but these libraries cannot depend on the application. And so this helps you having more maintainable and clean code in general. Having low coupling or no coupling is something that well, no is impossible, but very low coupling is something you should aim on every time when you do good software, but libraries makes this, well, for free. You have to do it. So let's see what are some ways, some techniques to create libraries. So the first one that I already mentioned implicitly is to extract some code from an existing project. So I have my project. I made the function, I made that feature that I was about to, which was the main scope of this project. And then I want to extract it, maybe to reuse it on different projects. So the first thing to do is to simply create a dedicated module. And when you are going to do it with Android Studio or IntelliJ, you will see immediately that it's going to be an Android library module. And as the name suggests, that's the first step to create an independent library. As mentioned before, you should try to have a one-directional relationship between the core app and this new module so that it can be easily extracted. This is good already to have to improve modularization of your app. If you saw the talk that was already there, there was immediately before this one in the central stage. I didn't because I was following this one. It was about modularization. Check it out because modularization is something very important in general for modern applications. So we have our Gradle module with just the interesting and needed the bare minimum classes required for our library. What we want to do then is to make it available for other projects so that, again, ourselves or other third-party developers can benefit from the work we have done. So we go extracting it and making it into a dedicated project. This project then is not part of our core project anymore, and we need to have a way to distribute it. And what is usually used is to publish this project, this library, into a library repository. We will see later there are several options, some more common, some easiest, and there are definitely a lot of utility plugins that we can use to do it in a very, very painless way. So what we have seen so far is how do you usually proceed when you are going to create a library from scratch. But sometimes you don't need to. Sometimes you are already using a library, or there are a lot of libraries available already from a lot of very talented people. But maybe they are not covering all the use cases that your application needs to do. So what you can do is to fork it. You can start from an existing library, so you don't have to reinvent the wheel, but you can extend it. Of course, the quickest way, best way would be if the owner of this library agrees it, is to accept some contributions from you. So you can add new features, you can suggest or request new features, but that could never, it's not guaranteed that is accepted. Also consider that maybe you are covering such an edge case that the original owner is not interested. So what you can do is to fork it, create a new library from the existing one, of course, if the license allows it, and then you can publish it under your name. Everything that I described so far has happened with one of the libraries that I've been working on at Novoda for the last year or so, which is the Novoda Download Manager. As the name suggests, it's a library that is used to download stuff. It was forked in 2014, I think, from the OSP Download Manager. So we started from something existing, as I just explained, we forked it, and we added some new features because we needed it for a couple of clients' projects. First of all, back in the days, I don't know what's the status now with the OSP Download Manager, but back in the days, it allowed only to download on the external storage of the phone. So something that we added is the possibility to download it to internal storage. We also wanted to have the possibility to download multiple files, but in a transparent way for the user. So with OSP 1, every single file downloaded could be queued, but each one of them would have had their own notification, their own progress, etc. So there were ways of having just one notification for the whole set of files, but it was very tricky. So what we've done was to change the whole notification system of the original download manager and to make it basically allow us to batch set of files into a single one and have one single progress, making it transparent for the user. And finally, we wanted more flexibility regarding rules to where to start, where to allow, or where to block downloads. This worked quite okay, but it was very limited due to the, let's say, the architectural choices, let's be polite, that were done for OSP, the original OSP download manager. So what we've done in the last year, we rewrote it from scratch. So we went from the other approach that I described, and we started creating a brand new library. Of course, we kept the same requirements from the previous one, but we improved it a lot. Basically, in this one, it's even easier. We changed all the APIs, so it's way easier to batch files and to create batches with multiple files or even single ones. But it requires very, very few lines of code. We allowed more control to the client app. So, for example, it's very easy to specify some rules where to allow or deny downloads, depending on the connection, storage availability, or other conditions. It's so easy to customize notifications. So we will see later an example, but basically, client applications, they can easily customize when to show notification depending on the status of a download, or customize all the aspects, including views, colors, styles, themes, everything. And finally, another important thing is that it's possible to to choose where to download files. So internally, externally, microSD, whatever, you name it. Internally, so under the hood, we replaced SQL with Room. And in general, we created a way better API to query in order to allow the client application to be notified regarding the status of downloads. Uh, and this basically was I think one of the best things that we did, because it allowed us to get rid of content providers and content resolvers, which in the OSP version they were exposed publicly with all the negative effect for this. So again, what we did when we started working on this one was to solve the simplest problem. So simply creating a library, something that allowed us to download a set of files. Then we added more things like the customization, we added the batching, we added the querying, etc. Something that we saw and that were very important for us, and also when working on open source libraries for third-party clients, is the ability to customize it, but also providing some defaults for everything. So in our library, basically, to create a new download manager is as simple as that. There is a builder class, and then you can just call it with a very, very small amount of parameters. That's only what is needed to create the download manager, and then you can use it to query and to download new files. But this is very, very very customizable. It can be expanded a lot by the client applications. There are a lot of utility methods and a lot of other collaborators of the download manager, which all have a default value, but every single client application can customize. So for example, the HTTP client. Under the hood, we use OK HTTP, but every client application can provide their own HTTP client. So they can attach any listener, they can customize it, they can change it whatever you want. The same is for downloaders. So by default, the library is used to download from the internet. But you can specify a downloader which might be used to download from one partition to another in the device location. If you need to do, I don't know, for example, moving big files, that's a good way to have it in a tracked way. So all these methods that we used in the builder, they are expecting an implementation of interfaces that we define. So for example, regarding the notification customizer, we created this interface. And this allows the client application to react to what we expose. So we are querying, in this case, we are querying the client application saying, OK, I have this update, this status for the download of this specific type. What do you want to do? How do you want to create and customize the notification? And this is just an example. We did it for every part that can be customized by third-party applications. One tool, and well, one methodology we can call it that we used a lot during development is the use of a demo application. I call it as a methodology because that's maybe you are considering demo applications in libraries, especially in open source libraries, as just a way to show to potential users of your library how to use it. So some edge cases, how to instantiate it in a real world scenario. But for us, was way more than that. So first of all, it puts you in the mindset of a user, a developer, using your library in the future. So using this application together with your app, your library, it allowed you to see how that one is going to be used in a real world application. It's good to keep it as simple as possible so that it doesn't have any other dependencies that can have any side effect with your application, and also to make it easier for new users to read it, to understand it. But it's very important to quickly test new functionalities before releasing a new version of the library. Something that is really interesting is that we use it a lot when we have any bug reports or weird behaviors, because in this one, using this small application is way easier to test that the library is behaving correctly. And especially it's very useful when we have a bug report from a third-party developer, where they can have some weird behavior, weird edge cases or bugs in their project. We always encourage them to try to reproduce the same scenario in our demo app. It's very simple. There are very, very few lines of code. And here you can immediately see if it was a problem in their configuration or it's actually a bug in our library. In this case, OK, it's very simple for us to replicate given the small nature of this app. This one probably is the thing that we have been using more, and I really encourage you to do if you are going to create a library application, a library for Android. So once you have created it, probably you want to share your library with the world. You want to share it with third-party developers. A good thing that we usually do in our with our libraries is to publish them as open source projects. I'm not going to go into the licensing part, like all the available open source licenses that are available for open source project, because that one could be material for dozens of talks alone. What I'm going to explain here is some of the things that you should consider when creating and maintaining, especially a library open source project. So first of all, consider the README. README is the first showcase of your library. It's the first thing that new users, new potential developer users is going to see when they are approaching your library. So something to consider is that you need to show quickly how they could implement your library, how they can integrate it with their project. So showing the group ID, artifact ID, all the small snippets that they have to add into their Gradle configuration, and how to create a very basic, a very simple use case for your library. So in our case, we don't show all the customizations that I showed you before. For this, there is the demo app, or maybe a dedicated wiki page, or more wiki pages. In the README, you just need to show the very basic stuff that they need to use in order to get up and start using your library. So one of the good things about open source is that you are sharing your project with the world, and you can get feedback from the world. You can have contributions. So something that is good to consider, is good to remember, is that you need to be present, because nobody wants to, use, first of all, but also to comment or interact with a project that is abandoned and is not followed. So try to address comments, feature requests, issues as soon as possible, but also ask for comments, ask for more details if they are needed. Also regarding especially feature requests, it's good to be opinionated. It's good to say no. You don't have to accept and work on all the feature requests that the third-party users are asking. If they want to change radically your library and maybe taking it on a direction that you don't really care about, they can still fork it, as we explained before. But always try to provide some evidence. Try to provide a reasoning why you don't want to follow that route. It's not good to just say, no, I don't care, I don't like your idea. Always try to explain it. This is something that, unfortunately, we should always do online in general, but even more if you are contributing and maintaining an open source project. Something that can make your life way easier, especially with pull requests, especially with issues and feature requests, are templates. So templates are a feature in GitHub that allows you to pre-populate the text areas, basically, where user can, all the developers, sorry, can input some text. So for pull requests, for issues, for feature requests, etc. You just need to create some markdown files and post it in the, there are several paths where you can post it. One is the .github folder, which is good because it's also hidden. You can also put it put them into the root or docs folder, we usually have the convention of putting these into GitHub one. Again, they are very important, especially for issues, because you can pre-populate them, as you can see, well, not very much now, but yeah, you can pre-populate with all the information you need. So you can pre-populate the text with a checklist that developers need to follow when they are going to submit something to you. Okay. Another tool that we use a lot, well, in our projects in general, but especially in open source ones, is a continuous integration system. If you don't know what a continuous integration system, or CI from now on, is, there was a talk yesterday which was very interesting about the topic. I highly recommend to have a look at the slides or the recording when they will be available. But basically, is a set of tools or services that perform a repetitive set of tasks in an automatic way. And basically, they keep your project checked while it progresses, while it's modified. So what do we do it? How do we do it? Basically, a bit of the background. In all our projects, so also in our libraries, we always use a Git flow or similar approach. So every change is done in a feature branch, which is then merged to develop. And when the library is ready to be published, these changes are merged into a release branch. So our continuous integration performs a set of checks. So for example, static analysis, tests, etc., every time that we open a pull request. So that we are sure that all the changes that we are introducing to our libraries, they are checked and they are not introducing bugs, for what is possible to do with tests and static analysis, of course. We check that the style is consistent, etc., etc. This is done through a set of plugins and a pull request builder, which does these checks every time the pull request is open. Also, we do the checks, of course, when the new changes are then merged into develop or releases, and we automated as well all the release process, which we will see in a second. Before continuing, I didn't mention a lot about tests for two reasons. Well, as I mentioned before, libraries are just a Gradle module in the end, glorified Gradle modules, because they are now evolved into standalone projects. But in the end, you can test them as you would test a regular Gradle module. There is nothing much special about it. And another very positive thing regarding the demo application that I mentioned before, I really can't stress enough the importance of that, is that allows you to test not only the inner part of your library, but also how the library is going to interact with a user interface. Because in that case, you can run espresso tests into that small demo app, which is going to be very stupid. There are not going to be animations or fancy UIs, but it's going to be very easy to test the core of what is really important for your library. And again, all this can be automated again using a continuous integration system. So we have our library, which is tested, which is automated in this repository, shared with the world, but it's still not accessible by Gradle when we are compiling and when we are building another project. How we do that? We need to publish it to a shared library repository. There are several available. One of the most famous ones, and the one that we use, is JCenter, which is a repo hosted by Bintray. This is a repo where artifacts or compiled part of the application of libraries are hosted, and they are available using a given syntax for the Gradle build system for third-party projects. There are several ways to upload the libraries to Bintray. The easiest one is to use another Gradle plugin that we created, which is the Bintray release plugin. This is a plugin that you can add to your library, and with just a few lines of code, you can configure it in order to automatically upload your library, automatically when you want it, with just a simple Bintray upload Gradle command. As you can see, it's pretty intuitive how to configure it. You just need to give a description, the group ID, artifact ID, and versions, which are the same that will be used by Gradle later when downloading it for the compilation of a third-party project. And the plugin is going to do all the uploading, all the compilation, all the bundling that is needed in order to upload it and publish it to Bintray. Just just a small diversion regarding versioning. Um, Maybe you already know it, maybe not, but the use of three numbers separated by dots as a name when we are talking about software in general versioning, and is called semantic versioning. It's basically used to make a distinction between a small update and a big update in general. There are three numbers. The main one is the major one, and is the one that you should use when you make some big changes, adding very substantial features, or in case of libraries, when you are making incompatible API changes. You know that your clients should know that if there is a major update, there might be issues. Well, issues. There might be some problems that they need to fix in their side as well because API changed. Um, Minor ones are basically means that you added some new features, but maybe they were just new. They didn't break anything from what was existing, while patch ones are very small changes like bug fix, etc. In general, a process that we try to use is when we are going to change some APIs, we do it in a couple of releases. So in the first release, we deprecate the old version, but still keeping it, and providing some fallbacks, while in the next one, we do a major release, and then we completely remove the old APIs. This gives our libraries clients a bit of time and a transition period when they can easily follow the deprecation and remove everything without having breaking builds. Okay, so let's have a look at the typical release flow when you are going to do some changes to an Android library or to a library in general. So let's say we are starting from version 1 of our library. We want to do some changes, and then we want to update to publish it with the version 1.1 because we are adding some new stuff. So we change the version name, and we change it to 1.1-snapshot. This means that these releases are not meant to be final. They are just for a work in progress. You can consider them as nightly builds, even if they are not built during the night. So what we do our changes in the library update step. We do what we want to do. From the beginning, we do a snapshot release, which again is not public, can be public, but is definitely not to be meant to be used in production code. We test it in our client, and then QA found a bug, of course. So what we do is that we do another update. We probably increase the version number as well. So we increase it to snapshot 2, snapshot 3, etc., etc. And every time we do a new release. Until we are satisfied, we update the version again to this time 1.1.0 without snapshot, and we release it. At the time, it's ready for the public finally. This is very time consuming, especially the library update, the version update every time, and then doing a snapshot release for every single build. Something that was recently introduced by Gradle is the use of composite builds. Composite, I never remember how to pronounce it. As the name suggests, it's a way to introduce on the same project multiple builds that were supposed to be independent, like in this case. If we add this include build in the settings.gradle of our client application, we can specify a relative path where a library project source code is located, and the two builds are going to be connected together. The good thing and IntelliJ already support it by default, and what happens when you do this is that you are going to see all the code for your library, the one that you are including with include build, in the same window as the project one. It's something that happens already when you include that library using just Gradle. But in this case, and this is the good thing, you can edit that code because you have access of the actual source code of your library in your machine file system. So if you spot a bug, if you are seeing that if you want to change something, you can immediately change an API in the library, compile, and you will have the same library changes reflected in your client project. So in this case, you can simplify the release process a lot, just removing all the snapshot releases, and then you can release immediately, test immediately in the client project, and release it to production when it's ready, of course. Something that I mentioned before is that one of the things that our CI does for for library projects is automated releases. This means that every time a pull request is merged into develop, so for every single feature, we do a snapshot release. This is completely automated, and it allows us to have small advancement, let's say, in the development of our project, and then we can test more frequently in client projects as well. By default, snapshots are private, but we've chosen to make them public for most of our libraries because for openness, basically. If a developer want to try, they can easily try snapshot releases, because sometimes we are waiting to accumulate multiple new features to have a public release, but those snapshots can be tested. Always bear in mind that it's not a final one. Public releases are automatically made when we finally merge everything from develop into release. Okay, so to recap, what we've seen so far is that libraries are good because they allow us to have a small scope to focus on a small set of features that we want to cover. They allow us to prevent coupling because they have a unidirectional communication between the project and the library. And they are a good solution to reuse code and solution to problems in different projects. We can create them starting from a dedicated module or forking an existing library, and then they can be evolved, generalizing more to provide more flexibility to third-party projects. It's very important to remember, use, create, and maintain a decent demo app, because that's not only useful to show what you have done, but also to test it and to reproduce potential issues. For open source projects, remember to have a good, clear README with all the information that a new user for your library needs to know. And then templates are very powerful, and continuous integration to keep the good quality of your library or any project in general. And finally, remember semantic versioning when releasing. Composite builds will save you a lot of time, and a lot of releases you can avoid. And finally, having automated release is gonna remove one pain point from developers and to make everything basically quicker and faster. So thank you very much. If you have any question.